Hello and welcome to Tuesday Science. Now we will be in the kitchen later because we are going to carry out an investigation. But before we do that, we are going to have a look at what we're going to be investigating. So we're going to be looking at the effect of temperature on the process of evaporation. Okay, so let's think about what evaporation is. I'm just going to share my screen and then I've got a little clip to show you.
So, I've heard a rumour that you can change liquids to gases and back again. Right, go on then, let's see. Nice shower square. Whoop, cheeky. When water is heated up, it changes state from a liquid to a gas called steam, and this process is called evaporation. When a gas cools down, it can change state back into a liquid. So when the warm steam hits the surface of, say, a cold mirror, it turns back into water again. This change is called condensation. The process can be reversed again if we warm up the liquid. Oh, hang on. Time to get out of here, I think. You really should have locked that door.
Okay, so evaporation happens when something gets warm, gets hot. So we've looked already at the water cycle, looking at the water in the seas and the lakes, and the sun warms it up and it begins to evaporate. It goes up and it condenses, the clouds condense, and then we get the rain. We're going to take that idea of evaporation and we're going to put it with an investigation of how clothes dry. How do wet clothes dry? Okay, so I've got some children's ideas. So the first one, I think the clothes dry because the sun heats up all the particles in the liquid until it is boiling. When it is boiling, the particles move around so much that they can escape from the wet clothes as steam. Then the clothes will be dry. What do you think? Do you think that's right? What about this one? How do wet clothes dry? Well, when clothes hang on the washing line, the water is absorbed into the clothes by the sun. When they've been on the washing line for long enough, all the water will be absorbed and the clothes will be dry. Do you think clothes dry by absorbing the water? Think about when you've been swimming and you've got a wet swimming costume. Does the swimming costume continue to absorb? No, that's not how wet clothes dry, is it? Let's see if this one's right. The sun shines on the wet clothes and sucks the particles of liquid out of the clothes. Sucks it out. The liquid turns into air and the clothes will be dry. Well, that's an interesting idea, but even when it's not sunny, I can get clothes to dry. So that's not right. Oh, what about this one? The particles in a liquid have energy and are moving around each other quite fast. Some of the particles move so quickly that they turn to a gas and move away from the liquid. This happens quickly if the liquid is boiling, but when clothes are drying, it is not that hot. So I think it just happens slower. Eventually, all the particles will have changed into a gas and the clothes will be dry. That is spot on. So, how do wet clothes dry? Well, the particles in a liquid have energy and they move around. Some of the particles move so quickly they turn into a gas and move away from the liquid. It happens quickly if a liquid is boiling. Do you remember the kettle? The steam and the evaporation, or like the clip I just showed you, in the shower, it gets hotter much quicker. So it's going to happen slower. So wet clothes dry by the liquid evaporating. Now we're going to see what is the best environment for the liquid to evaporate. So what we're going to do is I'm going to tell you about some equipment that I've got, and I'd like you to have a think about how we could use this equipment to create an investigation. So I've got some bowls, got a measuring jug, got some water, I've got some tea towels, got 3 tea towels, got a timer, got some pegs, and I'll have some scales, some weighing scales, some measuring scales as well. So I'd like to have a think about how we can use the equipment to investigate the effect of temperature on the process of evaporation. What could we do? Okay, welcome back. Did you have a think about what we could do with the items that I told you about to investigate how temperature affects evaporation? Thinking about how do clothes dry? Right, well, instead of clothes, we're going to have tea towels, and I've got 3 identical tea towels. It's important in an investigation to have things the same, because we want to make sure that our results are accurate. So I've got 3 tea towels, got 3 bowls. Now they're not the same, but that's okay because they're just a container, and I didn't have 3 exactly the same, but they're a container for the next part. I've got the scales, got the clock, got a measuring jug, and actually I've got a measuring cup as well, and I've got some pegs. So we're going to investigate how do clothes dry. So here's what we're going to do. I wish I could have heard some of your answers and some of your ideas for this investigation. I bet they were brilliant. We're going to put the 3 tea towels, we're going to put 1 tea towel in each bowl. Okay, actually I'm going to open them up a bit, like that. I'm going to open them up. Okay, and then I'm going to put on an equal amount of water on each one. Okay. So we're going to make sure that we put the same amount of liquid on each tea towel. The tea towels are representing the clothes. So I'm going to measure out 300 millilitres of liquid, and I'm going to pour it over the tea towel. And I'm going to do the same for all of them. Okay, and then I'm going to wait a few minutes for the tea towels to absorb the water and to behave like clothes, as though they come out of the washing machine. So I'm just going to leave those for a couple of minutes to just absorb all the water. So for a couple of minutes, these tea towels have been absorbing the water and they are now fully saturated. So what was the investigation title? It was to see how temperature affects the rate of evaporation. So how temperature affects how clothes dry. So what we're going to do is we're going to put these 3 tea towels in 3 different environments to see whether they dry, whether the water evaporates differently in different temperatures. So we're going to have 1 tea towel and we're going to pop that on a radiator that's been on, so a warm radiator. I'm going to get my pegs and I'm going to take this one and put it on the washing line outside. And then this one, I'm going to put it on the clothes dryer inside. So it's not going to be on a radiator, but it's going to be inside. So we've got on a radiator, we've got outside, and then we've got inside but not on a radiator. So what we need to do is, in order to make sure we know how much water is evaporated, we're going to weigh each of these tea towels to make sure we know the starting weight. Now, theoretically, they are exactly the same tea towels and we put exactly the same amount of water on, but we need to make sure. So I'm going to use my scales. I'm going to zero it So I've got 0 and I'm going to put my tea towel on. And that tea towel weighs 391. Okay, let's do the same. So 0ing it. That tea towel weighs 392. Slightly different. And this one weighs 392 as well. So we're going to be taking it as 392. What we're going to do is we're going to place these in their different environments for 1 hour, for 60 minutes. Then we're going to come back and weigh them again and see how much they weigh, and that'll tell us how much water has evaporated. Okay, see you in 1 hour. Okay, so it has been 1 hour drying time. Now, if we had longer, we might do after 1 hour, after 2 hours, maybe after 3 hours. And that would perhaps give us an indication of the rate of drying. So let's recap. By the end of this lesson, I want you to be able to explain the effect of temperature on the process of evaporation. So we've got our 3 different tea towels, and we've got the different places they've been. So let's start with outside. Okay, so we've got outside. Now, just to remind you, it was 392 grams to begin with. Okay, and it is now 318. So has any of the liquid evaporated outside? Well, it would appear so, wouldn't it? It's gone from 392 down to 318. Some of that liquid has evaporated. It's also incredibly cold, and when I got it off the washing line, it was actually stiff and frozen. So I'm amazed it's actually evaporated at all. Now we've got the inside drying rack. Okay, inside drying rack is the next one. So reminder that it again started on 392. I'm zeroing my scales, sorry, my scales down here, and zeroing my scales, and I'm going to put it in. Now, do you think that it will have lost more or less being inside? Well, if you guess less, you are right, but not as less as I thought it was going to be. This one is actually now 314 grams when I weigh it. So despite the fact that that my tea towel that's been outside was so much colder, I mean, this feels warmer, but it hasn't evaporated that much more. Maybe I need to have a look at where I have my drying rack. Maybe it's too far away from a heat source. Okay, and this is my last one. I've got my last tea towel, and this one was on the radiator. So, same as before, I'm going to zero my scales, and I'm going to pop it on top. And that one weighs 250 grams. 250 grams. Okay, so we've got outside was 318, inside drying rack 314, and on the radiator 250. So those are the 3 towels. What I'd like you to do now is below this video is a PDF, and it has a copy of this. Now this is the 3-star. There is a 1-star and a 3-star. Have a go at the 3-star. It's got questions on it, so if you can't print it off, don't worry, just copy out the questions. The first one is, what did you observe or measure in towel 1, 2 or 3? What did we measure? What was your conclusion? Can you answer the question? And the question is, does the temperature affect how fast towels dry? So did the temperature affect how fast the towel was drying? And can you explain why that happened? Think back to this boy here, when he talked about it was drying and there was a process that was happening. It was happening quite slowly. What was that process? Begins with E. Okay, sorry we had to go out of the kitchen to conclude the science, but Mr. Rudkin wanted to use the kitchen, so I had to leave the kitchen for the end of the science experiment. I hope you've enjoyed it. I look forward to seeing your conclusions sent to us today.